We are the first in the world to build a multi-scale system for Earth inspection. Cosine is building innovative measurement systems since about 20 years for space and non-space applications. We have hardware flying towards asteroids as part of the Hayabusa 2 mission, and we have built hardware for the International Space Station to take high-resolution pictures at night of the Earth, and this helped scientists to understand better the light pollution issue. In 2014, we have kick-started our internal multi-scale program to help inspecting the Earth as frequent as possible at different detail scales. We want to provide a deep insight of what is happening worldwide, and for this, flight models are being built in our clean rooms right now. Satellites are becoming more and more affordable. Thanks to this, innovative applications are enabled. Think about the potential of having fleets of inspection systems deployed all around the Earth at different levels. We want to prevent disasters from happening where possible, or we want to help during emergencies themselves. For example, the flooding happening in China during these days, our early warning system could help the local authorities to understand the flooding delineation direction. Or the huge wildfire happening in Canada, our early warning system could help the fire brigades to understand the fire hazard beforehand. Besides the disaster management, we want also to help in the water management and also to let the agriculture become more affordable and efficient. To achieve this goal, we have 5 technology lines in-house. Hyperspectral imaging for land and water applications.
HyperScout is an hyperspectral imager for nanosatellite-based operations. It's based on a reflected telescope built with freeform technologies and a large sensor. The combination of optics plus sensor allows the instrument to have a very large field of view. And this field of view is sufficient for a few HyperScouts to image anywhere in the world every day. The geophysical parameters are calculated directly on board, so the users can have their information in real time.
The second one is infrared sensing, mainly for temperature mapping and precision agriculture.
Cosine is currently participating in an agricultural monitoring system, AMS. With smart technologies and new algorithms, we can measure the temperature of the earth, of fields, of crops from the sky. IRA is an airborne demonstrator of such an infrared cryogenic imager that allows us to give to farmers and local authorities the information they need to move towards a brighter and more sustainable future.
The third one is imaging LiDAR, mainly for vegetation structure and bathymetry.
We are developing ALERT, a novel generation LiDAR for vegetation height retrieval from space. It is sensitive even to a single photon that is backscattered from the target vegetation, and it doesn't just retrieve the canopy height, but also its structure, as it emits a pattern of multiple laser beams. It emits nanosecond laser pulses with high repetition frequency, and the result is a very low power consumption instrument. Here we have an elegant breadboard of the system that has been successfully tested from an equipped tower in the Dutch woods.
The fourth one is polarimetry that we use for dust monitoring. And the fifth one is imaging spectroscopy, mainly for atmospheric chemistry and atmospheric pollution. Most of these technologies are also used for our planetary science and navigation instruments. We build sensors that can be deployed at multiple levels. The constellation is an early warning and change detection system, but a coarse resolution. If a change is detected, the same technology can be deployed on airplanes, on drones, even on ground vehicles for a very detailed analysis.
IRIS is a highly integrated instrument that combines the ALERT and HyperScout technologies into a very compact payload. This is the emitter optics of ALERT, and this is the telescope shared between the two instruments. IRIS is tailored for airborne imaging applications. It has been flown on both airplanes and drones to acquire hyperspectral images of land and water. These images can be used, for example, for irrigation monitoring, land cover change detection, and coastal monitoring.
We want our multi-scale system operational in 2023. The maiden space flight is going to take place in the beginning of 2017. We want our instruments on board of hundreds of satellites, of airplanes, of drones and on ground to help the world solving its problems.
Wow, wow.